Hi, third graders, it's Mrs. Compton, and today we're going to start off with a what do you notice? And of course, we always like to throw in a what do you wonder if you have wonderings in there too. So I'm going to show you the array that I have behind me. So this is what we are going to notice and wonder about. So I would love for you to hit pause and see all of the things that you notice and wonder. And don't just count the squares, get creative. Okay, hit pause. Did you get creative? I hope so. So I have to get creative when you get creative because I have to take some guesses as to what I think you may have done. So I'm going to guess that some of you did actually count the squares, but maybe you didn't count them one by one. Maybe you were actually strategizing. So I'm going to guess that some of you noticed that this is a 3 by array. I've got to count this part. 2, 4, 6, 8, 10, 12. Okay, so I'm guessing that some of you are probably thinking, all right, I can see that this is a 3 by 12 array. And maybe some of you counted them by actually considering what you know about 2 times 12. So did anybody actually do that? Like chop a line right here and think, all right, well, I know what 2 times 12 is. And 2 times 12 is, 2 groups of 12 is 24. So maybe somebody did that. And then maybe somebody said, well, this is just a 1 right here. So the 3 was broken into a 2 and a 1. And a 1 group of 12 is just 12. So I'm going to guess some people used their 2s to help them figure out this stuff and then added the 12 and the 24 together. So 12 plus 24 would give us 36. So that means some of you may have discovered that 3 times 12 is 36. Now let's draw another one because I'm going to take more guesses. So I'm going to draw the exact same area model. It is still a 3 by 12. Check my work, make sure it's still a 3 by 12. All right, and I'm going to take more guesses on how some of you guys got creative. So maybe, I just had a few thoughts. Okay, I'm going to guess that some of you probably realized there were 36 inside of here because did anyone break apart that 12? Did anyone break it into a friendly number? I'm going to guess so. So some of you may have done 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then draw that line right there. And then this part would be a 2. Dose. All right, so maybe you thought, okay, 3 groups of 10 make 10, 20, 30. So 3 groups of 10 make 30. And then 3 groups of 2 make 6. So I have to write that one small. 3 groups of 2 makes 6. You put them together and it still makes 36. 30 plus 6 is still 36. Okay, I have more ideas because you know what? I spent a lot of time in your 3rd grade classrooms last year and I did the same thing and you guys had so many things to tell me. So I'm just trying to remember what the kids were telling me last year. So I actually remember that some people got creative and broke things up in a way I didn't really think about. So I'm going to draw the same thing again, a 3 by 12. All right, so some people are actually fond of using multiplication equations or facts that they already know. They already have them memorized. So could you break this up in another way? You probably could. All right, so let's see. Maybe you decided to split the 12 in half because you know a 12 is made up of a 6 and another 6. 1, 2, 3, 4, 5, 6. Split. So 6 on that side and 6 on that side. Let's double check. Okay. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All righty. So we've got a 3 times 6 and another 3 times 6. So 3 groups of 6. All right. Let's count it out. 2, 4, 6. 6. Ooh, we could probably count by sixes. Do you guys know how to do that? 6, 12, 18. So 3 groups of 6 is 18. And that's exactly what it is on the other side. 6, 12, 18. 3 groups of 6 is 18. You add 18 plus 18, and what are you going to get? Well, it's going to be 36, right? Answer's not going to change. It's still going to be 36, no matter what way you think about it. Now, let's think about this. Let's get a multiplication equation for each one of these. So we did have multiplication equations in there, but could we do a longer expression? So let's think. Why don't we think about this one together? Let's see if we can think of a multiplication equation, just one equation, that would match this array. All right, so this might be a good time to hit pause so you can really think about it. I'm going to think about it too without hitting pause. You hit pause. Okay, I've got 2 equations that I've thought of so far. How many equations do you think of that might match this? Okay, so maybe you have 1, or maybe you have none, or maybe you have 2. Let's find out what's going on here. So you have 3 times 6. And maybe some of you are saying, well, I did that 3 times 6. I did that 2 times. So maybe you did it times 2. That would still give us 36. Or maybe some of you said, I'm going to change my color so you can see it's a different equation. Maybe some of you guys said, I did 3 times 6. Can you see this? I'm checking. Yes. 3 times 6 is 18. And then I just did it again. 3 times 6 is 18. Now, but that's not in one equation. So let's make it, actually forgot. Let's make it one equation. 3 times 6 plus, so you did that one, and then you did that one, and you added them together. So 3 times 6, that's the first group, plus another 3 times 6, that's the second group. You added them together, and it still makes 36. I think I'm officially the queen of squeaking stuff in. You guys, it's kind of crazy. Okay, so let's do a quick story problem together. So I'm going to hit pause. I'll see you back here in just a second. Stay right there. All right, I've got the story problem behind me. Here we go. The school assembly room has 5 rows of chairs with 20 chairs in each row. Where'd I go? All right. If the 3rd grade classes fill 3 rows of chairs, how many 3rd graders are at the assembly? All right, so we have to really think about the story, right? It's always important to have the picture in your mind. So the school assembly room has 5 rows of chairs with 20 chairs in each row. Okay, so imagine 5 rows, 1, 2, 3, 4, 5, 20 chairs in each row. If the 3rd grade classes fill 3 rows, so they don't fill the whole thing. There are probably 4th graders sitting behind them, right? Or parents, maybe, depending on what the performance is, right? What they're watching. So the 3rd grade classes fill 3 rows of chairs. How many 3rd graders are at the assembly? All right, so you need to make sure you have the picture in your head. Do you have it? 3 rows, 20 chairs. But there were also 2 more rows that didn't get filled. Let's look. So here's exactly what the story is telling us. Let's hang that there. All right, so we've got 5 rows, 1, 2, 3, 4, 5 rows of 20 chairs in a row. So this is 5 rows with 20 chairs in a row. Now maybe you're like, oh, I could count by 20s, or maybe you don't know how to count by 20s. But the main thing is we have to figure out how many 3rd grade classes fill 3 rows of chairs. I'm sorry, that was not the question. We have to figure out if the 3rd grade classes fill 3 rows of chairs, how many 3rd graders are at the assembly? Okay, so the 3rd graders are only going to fill up 3 out of the 5 rows. So that means these rows right here are not seated Third graders are not seated here, right? So those are out. In our minds, we're really just solving 3 groups of 20. So 3 times 20. So how might you do that? So let's think. We might just know what 3 times 20 is. Some of you might think about, well, 20 is actually split into a 10 plus another 10. So maybe you split it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So maybe we just split it right there and turn the 20 into a 10 and a 10. So we could do 3 times 10. So 3 times 10, you probably know, plus another 3 times 10. So that would be a 30 plus a 30. And that makes 60. See how breaking apart numbers, we can actually use things that we already know. First, we have to have the picture in our head. Second, it's helpful to draw out a picture and then ask yourself, what do I already know about this? All right, kids, I will see you next time. Bye.